Welcome to the second part of chapter 6. In this video, we are going to learn what's the difference between homogeneous and heterogeneous equation. Then we are going to learn how to write the Kp and also the Kc expression. Let's start with differentiate between homogeneous and heterogeneous reaction. For the reversible reaction, there is two conditions, homogeneous equilibrium or heterogeneous equilibrium. So if we look at here, for the homogeneous equilibrium, means that the substance, no matter reactant or product, all of them are in the same phase. So the phases here can refer to solid, liquid, gas, and also aqueous solution. As long as all the reactant and also all the product have similar phase, this equilibrium is considered homogeneous equilibrium. While the second one is the heterogeneous equilibrium, at where the product and also the reactant may have different phases. Okay, now we are going to start to learn how to write the law of mass action, which also considered as equilibrium law, or another terms is equilibrium constant expression. Means that these three terms actually they are referring to the same thing. A chemical reaction that is in a state of equilibrium is represented by a stoichiometry equation as follows. A mole of A react with B mole of B, produce C mole of C and D mole of D. If we look at this general equation, because all the phase for both reactant and product, all A, B, C, D are in gas. So we can say this one is homogeneous equilibrium. But when we want to write the Kp or Kc expression, this is the way. We look at the general. Okay, and here they are showing us the Kc. What is the meaning of C here? It is stand for concentration. How about this K stand for constant? And then the square bracket is represent concentration. So this is concentration of the product raised to the stoichiometry of the product C. Okay, so all these power in the Kc expression, actually they are referring coefficient in balanced chemical equation. And generally we can say up here is product, and then at the downside here is the reactant. Okay, again let's look back. What is the meaning of K? K is equilibrium constant. Value of K will be constant at certain temperature. Means that as long as the temperature is not changing, the value of K also will not be changed. But if the temperature change, the value of K will be changed as well. The equilibrium constant can be expressed in terms of Kc and Kp. So Kc, the C is stand for concentration, while the P here is stand for pressure. So because of C is stand for concentration, we can measure the concentration of gas, and we also can measure the concentration of aqueous. So if you are given an equation, only gases and aqueous substance will appear in Kc expression. While for the Kp, P is stand for pressure. So among solid, liquid, gas, and aqueous solution, basically only gas will exert the pressure. So means that only gas substance will appear in the Kp expression. Do keep in mind that liquid and solid never appear in the equilibrium law. Okay, now let's look at the details for the homogeneous equilibrium. This is the example of the homogeneous equilibrium at where you can notice that nitrogen, hydrogen, and also ammonia all are in the gaseous phase. All are same phase, so they are considered as homogeneous equilibrium. So if the question asks us to write the equilibrium constant, we can write the Kp expression, because in the previous slide we say for the species which are involved gas, we can write Kp expression. So how I'm going to write the Kp expression again, always is product over reactant. Okay, so what are the product for this case is the ammonia. So that's why I write P and H3. This P here is represent pressure and H3 is the product. So this 2 is represent the coefficient. Okay, divided by, because in this equation we only have one product. Okay, so we can continue with divide by the reactant. There are 2 reactants in this equation, nitrogen. The coefficient here will be considered as 1. So that's why if you look at here, partial pressure of nitrogen, there is no number, means they are to the power of 1. While another one is the hydrogen. So again, we write partial pressure for the hydrogen. And then this 3 is represent the coefficient. Okay, so this is the way that we write the Kp expression, include all the species which are in gas phase. Second, possible for us to write Kc expression? The answer is yes, because in the previous slide we say species which are gas and also aqueous can be appear in Kc expression. So there is a little bit different when we write the Kp and Kc expression. For the Kc expression, not just the P and C are different, and also the way. For the concentration, we are going to use square bracket. Okay, square bracket means concentration. So still similar, at the top here, we are represent with the NH3 ammonia, because ammonia is the product, while divide with the reactant, which include nitrogen. Here also, you want to put the number 1 is okay, or you don't want, also no problem. And also, another reactant, hydrogen, with the power of 3. Next, we are going to look at another example of the heterogeneous equilibrium. This is the example of the equation. Why we say this is heterogeneous equilibrium? If you notice in this equation, we can see there are solid, aqueous, and also solid. That means we have more than one type of phase, more than one type of phase. So that's why it is heterogeneous equilibrium. So for this for this equation, if you want to write the Kp expression, it is impossible, because as what we know, in the Kp expression, we only involve the gas substance. Here we have solid and aqueous only. So for this heterogeneous equilibrium, we are not able to write the Kp expression. However, we are able to write the Kc expression. But then if you look at the Kc expression, we didn't see any zinc and also the silver in the expression. Why? Because these 2 species, they are exist in solid phase. So if you still remember, we say solid and liquid never appear in Kp or Kc expression. So that's why for Kc we can include aqueous. So zinc 2 plus is the aqueous. Over the reactant side we have Ag plus, and then this coefficient is 2. So here we power with the 2. Okay, after looking at the 2 examples previously, basically I think you can answer the tutorial question number 2. Both 2A, 2B, and also C. Okay, before you continue with your tutorial question, maybe here I will discuss a few equations with you. Okay, for this first equation, we are able to write Kc expression, but we are not able to write Kp expression because there is no gas in the equation. For the second equation here, I can write Kc expression. I also can write Kp expression because gas are appear. For the third chemical equilibrium, again, we also can write Kc expression and we also can write Kp expression. For the fourth one, all are gases. So we consider can write Kc and also Kp. So this one is homogeneous equilibrium. The last one also involve all gases. So we can write Kc, we also can write Kp, and then this one also homogeneous equilibrium. Okay, so we sorry for not discussing this with you. So for this one, we will consider it is hetero because we have aqueous and solid and liquid. Three different physical states. For this one also said we have solid and gas, different physical state, so hetero. But for this the third equation, all reactant and product are gas. So this one are homogeneous equilibrium. Okay, look at the first chemical equilibrium. If I want to write the Kc expression, again, I will start with the product concentration HCl over concentration BiOCl. Why H2O and BiOHCl is not included? Because they are liquid and solid respectively. Okay, I hope with these 3 examples, you will have clear idea how to write Kp and Kc expression and also how to determine homogeneous and heterogeneous equilibrium.